Hello everyone. Today we are going to talk about the flow systems, activity relationships, space requirements in facility design and location lecture. Uh, let's start flow systems and activity relationships. Once we know what products we are making and what machines we need, the next big challenge is deciding how to group them inside the factory. An effective facility layout must minimize the total material flow cost and maximize the operational efficiency. To achieve this, we use systematic analysis. Today we will learn about two systematic analysis area. The first one is the departmental planning methods for cellular manufacturing actually using and second one is quantitative and qualitative flow measurements techniques. Let's start with cellular manufacturing. Uh, Cellular manufacturing and direct clustering algorithm DSA. Our first main objective is to understand how to design independent manufacturing cells of placing all similar machines together in a giant room. Cellular manufacturing groups different types of machines together to process a specific family of parts. Um, this drastically improves production flow. To group these machines and part efficiently, we can use direct clustering algorithm, which we call as DCA. The DCA has four clear mathematical steps, and our next algorithm is extremely similar with this four step. First, you are going to create a in in this matrix. In this matrix, uh, the the one rows represent the entries, machines, and parts. Uh, you, in second step, you are going to fill actually the cells with 1 and 0. In the third part, you are starting to reorder this matrix, sorting by rows and columns. You move the row in the entries in the leftmost columns to top, and columns with entries in the topmost rows to left. Uh, and finally, you identify a diagonal blocks actually, uh, and this reordering sorting will be finish. It's going to be optimal flow. In this cellular layouts, we can sometimes uh, leave some hardness with bottleneck. Uh, Firstly, we should know what's bottleneck, and then we need to look about bottlenecks solutions. Uh, Sometimes you will find the part that needs to be pro processed by a machine to belongs a completely different cell. We call this resource as bottleneck. Uh, for solving it, we have some solutions. The first one is agent machine positioning. Uh, if a bottleneck machine must be shared between multiple manufacturing cells, you can place those cells close to each other. Placing this shared resource right at the boundary minimizes material handling, distance, and travel time. The second one is part redesigning. You can work with engineering teams to redesign the problematic parts. The third one is outsourcing. You can choose to buy more complex parts from the suppliers. And the last alternative is machine duplication, but it might can be a cause of budget problem because you need to buy a new machine. In this slide, we're going to talk about rank order clustering algorithm. We're calling it as ROCA. Uh, ROCA uses a binary weight system to organize the matrix. Its procedure works like that. Uh, you assign the binary weights, which are powers of 2. Second, for each individual row, you calculate the decimal equivalent value. You do this by summing up the column weights wherever the row has an entry of 1. The third one is you rank all the rows based on these calculated decimal values and descending the order, like similar with the DSA. And finally, you are going to show a final entry, and it's going to be optimal flow. Now we are going to talk about measuring flow, quantitative and qualitative. This is going to be our actually second main objective. In this part, we are going to talk about flow measurement techniques. Uh, the quantitative and qualitative measures, as you can notice from their names, has a difference with numerical and non-numerical data. Quantitative flow measures are numerical. We use concert metrics such as pieces moved per hour, total weighted moved per shift, or volume transported daily. Uh, these values has a calculating exact numbers of cost, and the main tool is in here is from to chart. A from to chart is an asymmetric matrix because directional flow matters. Moving items from department A to B might be different from the B to A. Uh, In the second one is qualitative me flow measures. We are using it with non-numerical data if the numerical data is unavailable or when flow depends on non-material factors like communication needs or safety needs. Uh, then in this part where the primary tool going to be relationship chart. Before we were using from to chart, but now we are going to use relationship chart. Also, it has a closeness codes like A is absolutely necessary, A is especially important, A is important, O is ordinary closeness, U is unimportant, X is undesirable, like that. Uh, in flow analysis tools, uh, we have different parts. The first one is flow process charts. As you know, we used from to chart, and for building relations, we used flow diagrams, millet charts, from to charts, relationship charts. Thank you for watching this video. If you have any question, you can ask from the comment part. Thanks for watching.